Hello everyone, in this video we're going to learn how to solve rational equations. Alright, step number 1, we need to identify the restrictions, which is excluded values. Factor all denominators completely if possible. Set each unit factor equal to 0 and solve for variables. Step number 2, find the least common denominator, which is LCD. Build the LCD by listing each unit factor. The maximum number of times appears in the denominator. Step number 3, multiply every term by the LCD. So you're going to multiply every single term on both sides of the equation by the entire LCD. Because you're multiplying a fraction by its common denominator, the denominators will completely cancel out. You will be left with a clean, flat polynomial equation, no more fractions. Step number 4, solve the remaining equation. Distribute combined glide terms and solve the resulting equation using standard algebra. If it's a linear equation, get all the variables on one side and constants on the other side. If it's a quadratic equation, set it to 0 and solve by factoring, completing the square, or using the quadratic formula. Now, if you want to review how to solve quadratic equation by factoring, completing the square, or using the quadratic formula, please check out the link in the description below. Step number 5, check for extraneous solutions. Compare your final answer against the restrictions you found in step number 1. If a solution matches a restriction, it is an extraneous solution and must be crossed out. If no solution left, the equation has no solution. Now, example number 1. We're going to solve the following equation and identify extraneous solutions. Alright, step number 1, we need to factor denominator, right? So I'm going to use espresso for these three guys, right? Now for the first one, I need to find two numbers multiply equals 2 add up to 3, which is 1 and 2, right? For the second one right here, I need to find two numbers multiply equals negative 8 right here. Add up negative 2, right? Which is negative 4 and 2, right? And the third one right here, I need to find two numbers multiply equals negative 4 add up negative 3, right? So it could be negative 4 and 1, right? This equation becomes 2 over x plus 1 times x plus 2 right here, right? Plus 9 over x plus negative 4, so which is minus 4, right? Times x plus 2 right here, right? Equals 4 over x minus 4, which is right here, times x plus 1, which is right here, right? Now we're gonna find the LCD. We're gonna list the factor with the highest power, right? Look at this one, x plus 1. x plus 1 appears one time, right? So we have x plus 1. Now x plus 2 appears one time, right? And the last one, x minus 4. Alright, so this one is the LCD. We're gonna multiply both sides by LCD, right? So look at the bottom right here, we have x plus 1, x plus 2. If we multiply both sides by this guy, does that mean this guy cancel out? We only have x minus 4 left, right? So we have 2 times x minus 4 plus 9 times, we have x minus 4, x plus 2. So x minus 4, x plus 2 cancel out, we have x plus 1 left, right? So it's going to be 9 times x plus 1, right? Equals 4 times. Similarly, we have x plus 2 left, right? Now we distribute this one, so it will be 2x minus 8 plus 9x plus 9, right? equals 4s plus 8, right? 2s plus 9s could be 11s plus 1 equals 4s plus 8, right? Subtract 4s both sides, so it could be 7s. Subtract 1 both sides, so it could be 7, right? So s equals 1 is the final answer. We need to find the domain. Let LCD right here different from 0, so s plus 1 not equal to 0, right? S plus 2 not equal to 0, and s minus 4 not equal to 0, right? We solve this one. So we have s not equal to -1, right? S not equal to -2, and s not equal to 4, right? We look at this one right here, one different from these three guys, right? So this one is the solution, and we have no extraneous solutions, right? Now question B, we're gonna factor denominator, right? So we have 2s over 3s minus 5 minus s plus 1 over 3s plus 5 equals -4 over, this one actually different of 2 square. Remember, a square minus b square equals a minus b times a plus b, right? So 9s squared can be written as 3s altogether square, right? 25 can be written as 5 squared, right? So it's going to be 3s minus 5 times 3s plus 5, right? So we're going to put this over here. So we have LCD, which is 3s minus 5, right? Up here one time right here, times 3s plus 5 is going to be this guy and this guy right here, right? So we need to find the domain. We just let 3s minus 5 not equal to 0. We solve for s, so s not equal to 5 over 3, right? The second one, 3s plus 5 not equal to 0, and s not equal to -5 over 3. We multiply both sides by LCD right here, right? So look at the first one, you have 3s minus 5. If you multiply by this guy, and then you see that this guy and this guy cancel out, we only have this guy left, right? So we have 2s times 3s plus 5, right? Minus, don't forget parentheses, s plus 1 times, we have this guy and the LCD is right here. So this guy and this guy cancel out, we have this guy left, right? So we're going to multiply this guy by 3s minus 5 equals -4. That's it, right? Because the LCD right here, if you multiply both sides by LCD, this guy and this guy cancel out, we have -4 left, right? Now distribute this one, we have 6s squared plus 10s minus parentheses. S times 3s could be 3s squared. S times -5 could be -5s. 1 times 3s could be plus 3s. 1 times -5 is could be -5 equals -4, right? Now I'm going to distribute -1 over here, right? So I have 6s squared plus 10s minus 3s squared plus 5s minus 3s plus 5 equals -4, right? 6s squared minus 3s squared is going to be 3s squared, right? 10s plus 5s minus 3s is going to be plus 12s, right? And we're going to add 4 both sides, so it could be 9 equals 0, right? Divide both sides by 3, so it could be s squared plus 4s plus 3 equals 0, right? We're going to factor this one out, right? 5 two number multiply equals 3, add up to 4, which is 1 and 3, right? So it could be s plus 1 times s plus 3 equals 0, right? So this one is the 0 product. Each of these guys must be equals 0, right? So we have s plus 1 equals 0, and then s plus 3 equals 0, right? Now we're going to solve this one. So s equals -1, s equals -3. Look at these two numbers right here, different from the domain right here, right? So we have two real solutions and no extraneous solutions, right? Question C. We need to factor denominator out, right? So we have s minus 3 over 2s plus 1 plus 4x over 3x plus 5 equals 7x squared plus 12x minus 20 over. Now we need to find two numbers multiply equals 6 times 5, which is 30, add up to 13, right, which is 3 and 10, right? So 6x squared plus 13x plus 5 can be factor x plus 3 times x plus 10 right here, right? Now you need to be careful. The coefficient right here is 6, right? So you need to divide the constant right here by 6, divide this guy by 6, right? Now we're going to simplify, so it can be x plus 1 over 2 times x plus 5 over 3, right? Now we're going to multiply this guy back over here. So we have 2x plus 1 times 3x plus 5, right? We put it over here. Now we need to find the LCD. Alright, so we look at this one, we have the factor right here. This guy appears one time, so it could be 2x plus 1, right? This guy appears one time, so it could be 3x plus 5. This is the LCD, right? Now we need to find the domain. So we just let 2x plus 1 not equal to 0 and 3x plus 5 not equal to 0. We solve this one like we solve the equation, right? So we have x not equal to negative 1/2 and x not equal to negative 5 over 3, right? Now we're going to multiply both sides of this equation by the LCD right here, right? So we have 2x plus 1, 2x plus 1 cancel out. We only have 3x plus 5 left, right? So we have x minus 3 times 3x plus 5 plus 4x. This guy and this guy cancel out, so we have 2x plus 1 left, right? So it could be 2x plus 1 equals, the right hand side right here actually the LCD, right? So if you multiply both sides by the LCD, this guy and this guy cancel out, we have the numerator left, right? Alright, now we're going to distribute this one, so it could be 3x squared plus 5x minus 9x minus 15 plus 8x squared plus 4x equals 7x squared plus 12x minus 20, right? Now I'm gonna move every single term right here to the left hand side, right? 3x squared plus 8x squared, it could be 11x squared, subtract 7x squared, so it could be 4x squared, right? 5x minus 9x, it could be negative 4x, plus 4x could be 0, right? And you subtract 12x both sides, so it could be negative 12x. Now negative 15, if you add 20 both sides, so it could be plus 5 equals 0, right? Now we cannot solve this equation by factoring, right? So we need to use quadratic formula, right? So we have x equals negative b plus and minus square root of b squared minus 4ac over 2a, right? Where a equals 4, b equals negative 12, and c equals 5, right? So we just plug in values. It's going to be negative b, but b equals negative 12, so it turns out to be 12 plus and minus square root of b squared, which is 144, minus 4 times a times c. 4 times 4, it could be 16 times 5, it could be 80, right? Over 2 times 4, it could be 8. Now we're going to simplify this one. So it could be 12 plus and minus square root of 64, right? Over 8. And it's going to be 12 plus and minus square root of 64, it's going to be 8 over 8, right? So at this one, so at this times you have two possible values, right? We have 12 plus 8 divided by 8 and 12 minus 8 divided by 8. So it's going to be 20 divided by 8 and divide the top bottom by 4. It's going to be 5 over 2. Now this guy 4 over 8 divide the top bottom by 4, it's going to be 1/2, right? So you have two solutions right here. We're going to compare this guy with the domain right here. S must be not equal to negative 1/2. Yes, that's correct. This is 1/2. S not equal to negative 5/3. This is 5/2. So we have two real solutions, and we have no extraneous solutions, right? Example number 2. We need to solve the following equation and identify the extraneous solutions. So first, we need to find the domain. Now, domain, we just let the denominator not equal to 0, right? So we look at this one, denominator right here, right? So s not equal to 0, right? And this guy actually denominator of the fraction right here, right? So we have 8 plus 2 over s not equal to 0, right? We solve this one. So we have s not equal to 0. Now, since s not equal to 0, you can multiply both sides by s, right? So we have 8 times s plus 2 over s times s could be 2, right? 0 times s could be 0. So it's going to be s not equal to 0 and s not equal to negative 1 over 4. This one is the domain, right? So keep this one in mind. Now to solve this one, we just multiply the numerator and the denominator right here by s, right? So we have 3 over s equals 4 times s could be 4s. This cancel out, right? So it could be plus 1 over, similarly, 8 times s plus 2, right? Now, it's going to be 3 over s. This one right here can be written as 4s plus 1, and the bottom right here, you just factor 2 out. So it could be 4s plus 1, right? Now we look at the domain right here, s not equal to negative 1 over 4, which is this guy not equal to 0. We can cancel out this guy and this guy. So we're going to end up with 3 over s equals 1 over 2, right? Now cross multiply. So it's going to be s equal to 6. Now 6 different from 0 and negative 1 over 4. So 6 is the only solution, right? And there is no extraneous solutions, right? Now question B, we do exactly the same thing, right? So we need to find the domain, right? If you see denominator less denominator not equal to 0, right? So it's going to be right here, s minus 2 not equal to 0, right? And this guy right here, s not equal to 0, right? And the whole thing right here is the denominator, right? So it could be negative 3 over s minus 2 plus 6 over s not equal to 0, right? So it could be s not equal to 2, s not equal to 0, right? 6 over s not equal to 3 over s minus 2, right? We're going to cross multiply this one, so it's going to be 6 times s minus 12 not equal to 3s, right? And then subtract 3s both sides and add 12 both sides, so it could be 3s not equal to 12 and s not equal to 4, right? So we have the domains right here, s not equal to 2, 0, and 4, right? Now, from original equation right here, we just multiply both sides by denominator right here, right? And we just distribute this one, so it could be 2 plus 4 over s minus 2 equals 12 times negative 3, it could be negative 36 over s minus 2 plus 12 times 6 could be 72 over s, right? Now we're going to go back to the normal equation like we did in the example number 1, right? We need to find the LCD, right? So LCD is this guy right here. S minus 2 appears one time. And then S right here, right? Now we're going to multiply both sides by LCD, right? We have 2 times S minus 2, right? Now this guy has s minus 2, so we only miss s right here, right? So we have 4 times s equals, this guy has s minus 2, you only miss s, right? So it's going to be negative 36s, and this guy has s, so you miss s minus 2 right here, right? So it could be plus 72 times s minus 2, right? Now distribute this one, so we have 2s squared minus 4s plus 4s equals negative 36s plus 72s minus 144, right? Now we're going to simplify, so it could be 2s squared, this guy cancel out, equals this guy turns out to be 36s minus 144, right? Now we're going to subtract 36s both sides, so it could be 2s squared minus 36s and add 144 both sides, right? Equals 0. Divide both sides by 2, so it could be s squared minus 18s plus 72 equals 0, right? Now we're going to solve this one by factoring, right? So we need to find two numbers multiply equals 72, add up to negative 18, right? Which is negative 6 and negative 12, right? So this guy turns out to be s minus 6 times s minus 12 equals 0, right? So each of this guy must be equal to 0, right? S equals 6 and s equals 12, right? Now we're going to check these two solutions right here with the domain 2, 0, and 4. These guys satisfies, right? So these guys are solution to the equation and no extraneous solutions, right? Now example number 3, this one challenges. If you want to learn how to solve this equation, please check out the link in the description below. And it's your time to solve. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand